A sand dune does not do this. It cannot. The laws of granular physics are absolute. A mountain of loose, dry sand has no internal structure, no memory, no ability to hold a shape. And yet, on July 12th, 2013, a 126-foot tall sand dune in Indiana did something impossible. It swallowed a 6-year-old boy. The dune's name is Mount Baldi, a wandering giant on the shore of Lake Michigan, and Nathan Woessner was playing on its slope when the ground simply opened. A perfect 12-inch diameter hole appeared beneath his feet. He vanished. Not a landslide, not a slope collapse, a vertical disappearance. For 3 hours, a frantic rescue effort clawed at the sand, knowing that every second mattered, knowing that what they were seeing should not be real. Geoscientist Erin Argylen was there that day. She saw the hole. She knew that, unlike solid rock that can dissolve and form caverns, a dune is just a pile of sand. A void cannot exist. And then, 11 feet straight down, a rescue probe struck something soft. He was alive, buried for more than 3 hours, under 11 feet of sand that should have collapsed and crushed him in an instant. Nathan Woessner survived, and in doing so, he left science with a terrifying question. What else is lurking just beneath the surface? These lakes hold 21% of all the surface freshwater on Earth. We think we know them. We do not. The events unfolding within them are now moving faster than our ability to explain them. We're seeing geologic anomalies that defy physics, chemical reactions that turn the water into milk, and biological invasions that were considered impossible just a few years ago. The system is changing, and the rules we thought we understood no longer apply. Before we go any further, I want to ask you to do one thing. The vast majority of people who find value in these deep dives, people like you, simply forget to subscribe. If this kind of investigative documentary matters to you, please take 1 second now and hit that button. It's the only lifeline that allows a small channel like ours to continue this work. It genuinely is an emergency for us. So the real question is, are these isolated incidents, strange, disconnected curiosities, or are they signals of a much larger breakdown, a fundamental shift in one of the planet's most vital systems? The mystery of Mount Baldi didn't end with Nathan Woessner's rescue. It began. For Erin Argylen and her team, the question was not just what happened, but how. How does a column of empty space maintain its structure inside a mountain of shifting sand? The investigation took years. Using ground-penetrating radar, they scanned the dune's innards, mapping its hidden architecture, and they found ghosts. The dune is moving. It wanders inland at a rate of 5 to 10 feet every year, swallowing everything in its path. Decades ago, where the dune now stands, there was a black oak forest. The radar revealed the spectral outlines of those buried trees. As the dune rolled over the forest, it entombed the oaks. Underground, cut off from light and air, they began to rot. Fungus attacked the wood, decomposing it from the inside out. The theory they developed was as bizarre as the event itself. A buried tree trunk, hollowed out by fungus, leaves behind a perfect, rigid cast of itself made of sand held together by fungal residue. Eventually, this structure weakens. The top gives way, creating a sudden, vertical shaft, a chimney of nothing, a trap waiting for the weight of a footstep. They had found the mechanism, but it didn't solve the whole problem. It created a new one. How does the sand, even with some fungal binding, hold the shape of an 11-foot deep, perfectly cylindrical pipe without collapsing? The forces involved are immense. The sand should just pour into the void the second it forms. Instead, something holds it open, waiting. The physics still don't completely add up. Some scientists propose electrostatic forces between sand grains. Others suggest the specific geometry of the fungal rot creates a temporary, self-supporting arch. But no one knows for sure. The ground beneath your feet on that dune is not solid. It's a graveyard. And it's a graveyard with secrets it hasn't fully given up. The scientists are stumped, which means every theory is on the table. What do you think is holding these voids open? Let us know your hypothesis in the comments below. That day on Mount Baldi revealed a danger hidden in plain sight. But across the lakes, in the silent darkness of the lakebed, lies a far older and more profound anomaly. 25 kilometers southwest of Kingston, Ontario, beneath the cold, deep waters of Lake Ontario, there is a perfect circle. A depression in the lake floor, 1.5 kilometers wide, so geometrically precise it looks artificial. It's called Charity Shoal, and it shouldn't be there. It was first charted by the Canadian Hydrographic Service, a curious dip in the otherwise smooth lake bed. But it wasn't until 2001, when scientists surveyed it with high-resolution sonar, that its true nature was revealed. A circular basin with a raised central peak, the classic, undeniable anatomy of a meteorite impact crater. The age of the surrounding bedrock places the event in the Middle Ordovician period, around 450 million years ago, a time when life was just beginning to crawl onto land. The thinking was straightforward. A rock fell from the sky, struck the earth, and left a scar that was later flooded by the glaciers that formed the Great Lakes. A simple, elegant story. But the story is wrong, or at least it's incomplete. Because Charity Shoal isn't just a physical scar. It's a magnetic one. When geophysicists towed a magnetometer over the site, the readings they got back made no sense. They discovered a massive magnetic anomaly, greater than 1,400 nanoteslas, centered directly over the crater. That in itself is not unusual. Impact sites often have magnetic signatures. The problem is the direction. The magnetic field of Charity Shoal actively opposes Earth's main magnetic field. It's called remanent magnetization. When rock is heated to extreme temperatures and then cools, its magnetic minerals align with the Earth's magnetic field at that moment, locking in a snapshot of the planet's polarity. The Charity Shoal rock is magnetized in the opposite direction of the world around it. This suggests that when this structure formed, the Earth's magnetic poles were reversed. That's possible. The poles do flip over geologic time, but it complicates the simple meteor theory. It forced scientists to ask a different question. What if it's not an impact crater at all? An alternative theory is that it's a diatreme, the root of an ancient explosive volcano. A violent eruption of gas-rich magma from deep within the Earth could have punched a circular pipe through the bedrock. This happened in the Jurassic period, much later than the Ordovician. The shape fits, the size fits, but the magnetic signature remains difficult to explain. Another idea is that it's simply a massive karst sinkhole, formed when water dissolved a huge pocket of ancient limestone, causing a circular collapse. But the scale and the pronounced central peak make that unlikely. The final frustrating truth is that we can't be sure. The crater, whatever it is, lies buried beneath more than 30 meters of quaternary lake sediments. Thick, heavy mud deposited by the glaciers and the lake over thousands of years. It's a geological crime scene buried under a blanket of evidence-destroying silt. To know for sure what it is, meteor, volcano, or sinkhole, we would have to drill a core several kilometers deep, through the water, through the mud, and into the bedrock itself. An incredibly expensive and difficult operation. And so, it just sits there. A magnetic ghost on the bottom of Lake Ontario, a 450 million year old question mark that repels our compasses and resists our explanations. These mysteries force us to reconsider what's possible. If you find these hidden enigmas as deeply fascinating as we do, please hit that like button and share this documentary with just one other person who you think would appreciate it. Getting this information out there is more important now than ever. The more people who understand the forces at play, the better. The anomalies are not all ancient and geological. Some are happening right now, on the surface, on a scale that is difficult to comprehend. From space, they look like ethereal turquoise clouds swirling through the deep blue of the lakes. They can cover up to 58,000 square kilometers of water, an area roughly the size of West Virginia. They are called whiting events, and it is the lake itself spontaneously turning into chalk. For decades, boaters and residents saw these bizarre, milky blooms and assumed the worst: an industrial spill, a toxic algal bloom, pollution. But the water is perfectly safe. In fact, it's the opposite of pollution. It is a massive, spontaneous act of creation. The Great Lakes sit on a bed of limestone. The water is rich in dissolved calcium carbonate. A whiting event is what happens when that dissolved mineral suddenly decides to become a solid again. It precipitates out of the water column as microscopic calcite crystals, turning vast stretches of the lake a ghostly, opaque turquoise. An underwater blizzard in the middle of summer. We know the what. The mystery is the why. What is the trigger? The scientific community is split into two camps. The first camp argues for a purely physical explanation. They believe it's driven by temperature and water chemistry. As the surface water of the lake warms rapidly in the summer, its ability to hold dissolved calcium carbonate decreases. At the same time, photosynthesis by algae and other microorganisms consumes carbon dioxide from the water, which raises the pH. This combination, a rise in temperature and a rise in pH, pushes the water past a saturation point. The dissolved mineral can no longer stay dissolved. It crashes out of the solution, forming a cloud of calcite crystals. It's a question of simple, predictable chemistry. But a second camp believes the explanation is biological. They point to the presence of immense populations of tiny organisms called picoplankton, specifically a species of cyanobacteria named Synechococcus. They argue that these microscopic cells act as nucleation sites. The surface of each bacterial cell provides a perfect template, a microscopic seed onto which the calcite crystals can begin to form. In this model, the bacteria aren't just present during a whiting event. They are actively causing it. The blizzard isn't a weather event. It's a biological one. The evidence is confounding. Whiting events do correlate with temperature spikes and pH changes, but they also correlate perfectly with massive blooms of Synechococcus. So which is it? Physics or biology? Cause or correlation? Sediment cores drilled from the lake bed add another layer to the mystery. They provide a timeline, a history of these events written in layers of chalk, and that history is surprisingly short. Whiting events appear to begin in the sediment record only in the 1930s. They were not a common feature of the pre-industrial Great Lakes. Something changed in the 20th century that switched this process on. Was it a change in water temperature? A change in nutrient levels that favored the growth of picoplankton? Or something else entirely? The chalk clouds of Lake Michigan are a visible sign that the lake's fundamental chemistry is in flux. But deep beneath Lake Huron, in total darkness, a far more alien transformation is underway. A discovery that doesn't just change our understanding of the lakes, but our understanding of the entire history of life on Earth. To see it, you have to descend 80 feet beneath the surface of Lake Huron into the Thunder Bay National Marine Sanctuary. You leave the sunlit, oxygen-rich world behind and enter a place that feels like another planet. Here, groundwater that has been in contact with Paleozoic bedrock for thousands of years dissolves ancient limestone and gypsum deposits and vents upwards through cracks in the lake floor. They are sinkholes, like the Middle Island sinkhole, but they are venting, not draining. They pump out water that is intensely cold, almost devoid of oxygen, and rich in sulfates and other minerals from the 400-million-year-old rock below. It is a profoundly toxic environment for most life in the Great Lakes. Fish avoid it. Plants cannot grow. It is a dead zone. Except it's not dead. It is vibrantly, shockingly alive. The vents are carpeted with thick, vivid purple mats of bacteria, shimmering, moving curtains of life that thrive in this extreme, poisonous soup. Microbiologist Gregory Dick from the University of Michigan has led the research into these bizarre ecosystems. The organisms are a species of cyanobacteria called Formidium autumnale, and they are not just surviving here, they are dominating. They perform photosynthesis without producing oxygen, using sulfur instead. They are a window into a lost world. This is what Earth looked like billions of years ago. Before the Great Oxidation Event, before the atmosphere filled with the oxygen we breathe, the planet's oceans were likely filled with bacteria just like this. The Middle Island sinkhole is not just a geological feature. It is a time machine, a pocket of the ancient Earth, perfectly preserved in the cold depths of Lake Huron. But it was a 2021 study by geomicrobiologist Judith Klatt that revealed the most staggering secret of these purple mats. Her team took samples of the Formidium and studied them in the lab, recreating the conditions of the sinkhole. They were interested in the interplay between the purple sulfur-loving bacteria and their white oxygen-producing cousins that lived on top of them. At night, the sulfur bacteria would rise. During the day, the oxygen producers would migrate over them to reach the light. A daily dance. Then they had an idea. What if they changed the length of the day? They ran the experiment with 12 hours of light, then 16, then 20, then 24. What they found was astonishing. The amount of oxygen produced didn't just increase a little with a longer day. It exploded. A longer period of daylight allowed the oxygen-producing bacteria to dominate the mat for so long that they released far more oxygen than could be consumed by the rest of the chemical system. It was a tipping point, and it solved one of the biggest mysteries in planetary science. 2.5 billion years ago, the Earth's rotation was much faster. A day was much shorter. Then, as the moon's gravity pulled on the Earth, its rotation began to slow, and the days grew longer. The model from Klatt's team showed that as the day length on early Earth ticked past a certain number of hours, the exact same kind of bacterial mats would have suddenly started pumping out massive amounts of excess oxygen, enough to change the entire atmosphere of the planet. The Great Oxidation Event, the moment that made complex life like us possible, may have been triggered by the slowing of the planet's spin. The proof wasn't found in a distant star or a computer model. It was found in a purple mat of bacteria at the bottom of Lake Huron. NOAA scientist Steve Ruberg is now trying to answer a more practical, but equally urgent question. Just how much of this ancient, oxygen-poor groundwater is being pumped into the Great Lakes from these sinkhole networks? Even an inch of extra water in the lakes can make a difference, he says. But right now, the volume from these vents is a complete unknown. It's a variable in the Great Lakes complex water budget that we have never accounted for. And before we dive into the final, most alarming development in the lakes, I have to ask again. I know this is the second time, but if this journey into the unknown has taught you anything, or opened your eyes to something new, please take that 1 second to subscribe. A disturbingly high percentage of our viewers aren't subscribed, and hitting that button is the single most powerful way to secure the future of this channel. Thank you. All of these phenomena, the killer dune, the magnetic crater, the chalk clouds, the ancient time machine, are unfolding within a system that has, itself, become fundamentally unstable. The entire Great Lakes ecosystem is operating under a new set of rules, and it started with a single weather event. The 1997 to 1998 El Niño was one of the most powerful ever recorded. It warped weather patterns across the globe, and in the Great Lakes, it appears to have flipped a switch from which there was no turning back. In June of 2025, a study authored by Hazem Abdelhadi, a researcher at the University of Michigan, laid out the chilling data. Before 1998, The surface temperatures of the lakes were relatively stable. They followed predictable seasonal patterns. After 1998, they entered a new regime, a regime of extremes. Abdelhadi's research proved that the frequency of both extreme heat waves and extreme cold spells in the lake water has increased by over 100%. The appearance of these extreme temperatures is increasing, he stated. For most lakes, the appearance is up more than 100% compared with before 1998. This isn't a gradual warming trend. This is a permanent increase in volatility. The system's internal thermostat is broken. It now swings wildly from one extreme to another. The consequences of this new, chaotic reality are not theoretical. For decades, the frigid, deep waters of the upper Great Lakes, especially Lake Superior, acted as a powerful barrier, a thermal wall that prevented many invasive species from gaining a foothold. They simply could not survive the cold. That wall has now been breached. In June of 2026, the final domino fell. The bloody red shrimp, Hemimesis anomala, was officially confirmed to have established a reproducing population in Lake Superior. This was the one place it was never supposed to be able to live. A team led by Don Brandstrader, a biology professor at the University of Minnesota Duluth, collected 81 specimens in the Duluth Superior Harbor. Critically, those specimens included pregnant females. This wasn't a case of a few stray shrimp arriving in the ballast water of a ship. This was a thriving, self-sustaining colony. They had conquered the final lake. The bloody red shrimp is a tiny creature, but its impact is enormous. They are voracious eaters of plankton, the base of the entire aquatic food web. They swarm in dense clouds, outcompeting native species and fundamentally rewiring the flow of energy through the ecosystem. Their arrival in Lake Superior is not just another invasive species checklist item. It is the culmination of the new regime shift. The volatile temperatures, the warmer pockets of water, gave them the opening they needed. In his paper confirming the finding, Brandstrader delivered the grim verdict. Lake Superior now becomes the fifth and final Great Lake in which it is considered established. It is there, in perpetuity one would think, if they can continue to grow and reproduce. In perpetuity. The invasion is permanent. The change is irreversible. We look at the Great Lakes and see a map we recognize. 5 familiar shapes, holding 1/5 of the planet's fresh water. We see a resource, stable, dependable, timeless. But that is an illusion. The ground that seems solid can open up and swallow you whole. The floor of the lake hides geological scars with magnetic fields that defy our models. The water itself can transform into vast clouds of chalk before our eyes for reasons we still debate. And in its deepest corners, it holds living portals to the dawn of life, ecosystems that operate on rules so alien they rewrote the story of our own planet. These are not separate stories. They are chapters in the same book, the story of a profoundly complex, powerful, and ancient system that we have only ever partially understood. And that system is now under a new and unprecedented form of stress. The chaotic temperature regime that began in 1998 has broken the old climate patterns, allowing new organisms to take hold and fundamentally alter the biology of the lakes from the bottom up. The bloody red shrimp completing its conquest of Lake Superior is not the beginning of the crisis. It is a symptom of a crisis that has been building for decades, hidden beneath the waves. The uncomfortable question these anomalies force us to ask is a difficult one. We have built our cities, our industries, our lives around the assumption that the Great Lakes are a known quantity. But what if they are not? What if these bizarre events are not curiosities, but warnings? The system's way of telling us that the foundation is cracking, that the rules have changed, and that we are not prepared for what comes next. The science is racing to catch up, but the lakes are moving faster. The sand dune on the shore of Lake Michigan still wanders inland, holding its impossible secrets. The magnetic crater still sits in the darkness, a silent, powerful enigma. And the water that connects them all is behaving in ways we have never seen before. The tunnel is drilled. The water still flows. No, that's the wrong story. That was another place, another time. In the Great Lakes, the story is different. The mysteries are not being solved by human engineering. They are deepening. If you made it this far, you are part of a